Hello friends, in this video we are going to see how to solve a problem based on superposition theorem where there are more independent sources are present but one dependent source is always there. So here in this problem we are having 1, 2, 3 independent sources. So it's like 120 volt, 12 ampere and 40 volt are independent sources, and only dependent source, that is 10 IY, and I can say it's a current controlled voltage source. So this is the only dependent source present. And this depend upon this current IY which is flowing through 4 ohm. That's what we're supposed to find out also. So we have just listed out sources present, and what we have to do in a superposition theorem, one independent source at a time we have to consider replacing other independent sources by their internal resistances without changing the effect of dependent source. So let's consider 120 volt acting alone. So while considering that, 12 ampere being a current source, I will open circuit it. As we know, internal resistance of a current source is infinite, and 40 volt being a voltage source, we will replace it with a short circuit. As we know, ideal voltage source has internal resistance 0. So this will be open and this will be shorted. So what we will get over here, we will get a simple circuit consisting of only 120 volt acting alone. So let's draw the circuit for this. So let me write the statement. So what we are considering over here, 120 volt is acting alone, and what will happen to 12 ampere? 12 ampere is open circuited, and another voltage source which is 40 volt is short circuited. So we'll get a circuit like this. So we'll get a simple circuit consisting of only one loop. And this is the current IY. So let's maintain the notation same. That means here we'll have only one loop. Maybe we can keep the current same IY, and voltages across resistors will be like this. So it's very straightforward now. I will apply KVL to this loop to get the IY. Start from this voltage source. So it's 120 minus 4 IY plus minus 10 IY plus minus 8 IY equal to 0. So upon simplifying, I will get 120 equal to 22 IY, and upon solving this, I will get IY as 5.4545 ampere, and the current direction is same as whatever given by them. So I will get this answer very straightforward manner, but I will consider this is IY dash because this is only because of 120 volt acting alone. Let's go ahead and take the second source, which is 12 ampere. So now 12 ampere is acting alone. What will happen to 120 volt? 120 volt will be short circuited, being a voltage source. And another source is also voltage source, that is a 40 volt. So that will also be short circuited. So in the original circuit, what changes we have to make? This will be replaced by a short circuit, this will be replaced by a short circuit, so only current source will be present. So let's draw it. And this is a current IY on which there is a voltage depend, which is 10 IY. This time we have two loops, so two loop currents. Let's consider this as I1, this as I2. We will get the voltages like this. Now there is a current source between the two loops present, so we need to write the equation of current source first. By taking the current source out of the circuit, there are two currents. I1 is in this direction and I2 is in this direction. So if you see carefully, I2 current is matching with the current direction given with the current source. So I2 minus I1 is equal to 12. Let's rearrange the term properly. Minus I1 plus I2 equal to 12 as equation number 1. And second equation will be formed by applying a KVL to supermesh, which is a combination of mesh 1 and mesh 2, which is quite obvious over here. So let's start from here. Plus minus 4I1 plus minus 10IY plus minus 8I2 equal to 0. We need a substitution for IY, which is quite simple. So substitution equation for IY is nothing but IY is same as the I1. So wherever there is a IY, I will put I1. So if I do that, I will get an equation as minus 4I1 minus 10I1 minus 8I2 equal to 0. Upon simplifying, I will get minus 14I1 minus 8I2 equal to 0, equation number 2. Solving these two equations, we will get the values of I1 and I2. So we'll get the value of I1 as minus 4.3636 ampere and I2 as 7.6364 ampere. Now our objective is to get the IY, and IY is nothing but I1. So I can say IY same as I1 equal to minus 4.3636 ampere. Current direction will maintain as it is, and this is because of the second source 12 ampere, hence we'll mark it as IY double dash. Let's go ahead with the third source, that is 40 volt. So 40 volt is acting alone now. What will happen to 120 volt? Being a voltage source, we will replace it with a short circuit. So 120 volt is short circuited, and 12 ampere current source will be open circuited. So in the original circuit, we need to check what will happen. Over here, only this source is acting alone. 40 volt, 120 will be shorted, this will be open. So we will get a circuit like this. Current source is open circuited. We are not going to touch dependent source. So 40 volt is acting. And over here, this is a current that we are supposed to find out, and on which the voltage 10 IY depends. Once again, we'll consider only one loop is there, so IY is that current in the loop with the voltages across the register of this polarity. So let's apply KVL to this loop. Plus minus minus 4 IY plus minus minus 10 IY plus minus minus 8 IY plus minus 40 equal to 0. So if I simplify, I will get minus 22 IY equal to 40. So we will get IY as minus 40 by 22. So the answer for this equal to minus 1.8182 ampere. Will maintain the current action same as the given, and this IY is because of the third source, so we'll consider IY triple dash. Now we got three values, one because of each source. So because of the 120, we are getting a IY dash as 5.4545. So the total current, whenever we consider IY as algebraic sum of all these three currents. So first is 5.4545. Second is because of the current source 12 ampere, and that answer we obtain as minus 4.3636. You have to keep the minus sign as it is because we are considering the current directions are same for all the three. So this is minus 4.3636, and finally IY triple dash is minus 1.8182. And if we solve for this, we will get the value of IY as minus 0.7273 ampere in this direction only. And now we will correct the direction in the end, because we always want the positive values, so that can be obtained by changing the current direction. So ultimately I can say IY is 0.7273 ampere, current direction will be from this side. So this is the complete answer with the direction. I hope you understood the problem. Thank you.